Precision weighing determines the net yield, establishing the inventory baseline for the day's production.
Before unloading, laboratory technicians analyze samples for protein, gluten quality, and moisture content.
Only wheat meeting the strictest specifications is cleared for the milling process.
Gravity does the heavy lifting, emptying 40 tons of raw durum wheat in under 10 minutes.
From the intake pit, the wheat begins its ascent into the massive storage silos, ready for cleaning.
Before processing can begin, the raw wheat is elevated to the top of the cleaning house to utilize gravity flow.
The first line of defense removes ferrous metal contaminants that could damage the sensitive milling equipment downstream.
The large oscillating screens separate the wheat from coarse impurities like straw, strings, and stones based on size. Air currents lift away light impurities, leaving only the dense, healthy kernels to continue the journey. Using density differences, the destoner eliminates pebbles that are the exact same size as the wheat kernels.
Advanced optical sensors scan every single kernel, rejecting any that display discoloration or fungal damage.
Scouring removes dirt and mold adhering to the crease of the kernel, polishing the wheat for the milling stage. Water is added to toughen the outer bran layers, making them easier to peel off during grinding without shattering. The wheat rests for up to 24 hours, allowing the moisture to mellow the hard endosperm for efficient grinding.
Now fully cleaned and conditioned, the durum wheat is ready to be broken open. We now enter the heart of the facility, where the grain will be transformed into semolina.
The first break rolls merely crack the kernel open, aiming to release the endosperm without pulverizing the bran.
Pneumatic transport lifts the stock to the top floor, allowing gravity to feed the sifting process once again.
Inside this gyrating chest, stacked sieves sort the grind into coarse semolina, fine flour, and bran flakes.
The goal is to separate the pure, yellow endosperm from the brown, fiber-rich bran layers.
This cycle of grinding and sifting repeats multiple times, gradually scraping every bit of endosperm from the bran.
The bran is removed for animal feed or whole wheat products, leaving only the semolina for pasta.
Production rolls size the particles precisely, ensuring even water absorption during the kneading phase.
Pasta requires coarse semolina, not fine flour, to maintain its structure and al dente bite.
Purifiers use air and gravity to remove the tiniest specks of bran, ensuring the pasta's bright amber color.
It has become high-quality durum semolina. The finished semolina travels directly to the production line, never touching human hands. Precision scales weigh the incoming semolina to match it exactly with the water ratio.
Pure, filtered water is the only ingredient added to the semolina. Simplicity is key.
Digital dosing ensures the hydration level is exactly 30%.
High-speed blending hydrates the particles individually before they can clump together.
Removing oxygen prevents oxidation of the yellow pigments and strengthens the protein structure.
The dough is not beaten but pressed, allowing the gluten network to develop slowly.
The protein strands begin to link, forming the elastic gluten matrix that will hold the pasta together.
Friction generates heat, so the mixer is water-cooled to prevent the gluten from damaging.
Enormous pressure compresses the loose crumbs into a dense, solid dough ready for shaping. Over 100 bars of pressure are required to force the dense dough through the molds.
A final filtration ensures the dough is perfectly smooth before it meets the shaping die.
The shape of the pasta is determined here by heavy bronze or Teflon-coated dies.
Changing the die changes the product. A switch from spaghetti to penne takes less than 20 minutes.
Bronze dies create a rough surface that holds sauce better, while Teflon creates a smooth, durable finish.
The system ramps up slowly, stabilizing pressure to ensure uniform shape. The initial output is recycled until the dough temperature and consistency equalize. Once stabilized, the flow is continuous, a never-ending curtain of dough, preventing the fresh strands from fusing. Immediate surface drying is crucial to keep the shapes distinct during the next stage. Nothing is wasted. Trimmings are immediately re-kneaded into fresh dough.
Micrometer precision ensures that every strand of spaghetti cooks in exactly the same time.
With the shape formed, the continuous stream must now be cut to length.
Without vacuum, air bubbles would expand during boiling, causing the pasta to break apart.
The screw geometry is designed to compress the dough gradually, raising its temperature controlled by the water jacket. Too much friction destroys the protein network, and the process walks a fine line between pressure and heat. For short shapes, a rotating blade slices the dough instantly as it emerges from the die. A dull blade crushes the pasta shape. A sharp blade ensures a clean, open cut.
The dough is forced to split and fuse back together to create the hollow.
For fusilli, the die geometry forces the dough to rotate as it exits, creating the signature spiral.
Modern lines produce thousands of pieces per minute, a waterfall of shaped dough. The dough exits at roughly 50 degrees Celsius, warm and pliable. At this stage, the pasta is fragile and must be handled gently to preserve its shape.
The extrusion is complete. Now the shape must be locked in.
Violent shaking prevents the fresh pasta from sticking together while a crust forms on the surface.
For spaghetti, the dough is not chopped, but draped, cut only when it reaches the full rod length.
The pasta is hung on racks, a method that mimics the traditional sun drying on wooden poles. Uniform length is essential for packaging. The excess is once again recycled. Other shapes, like tagliatelle, are spun into nests to protect their fragile edges during drying. Complex shapes, like farfalle, require mechanical forming after extrusion to create the signature pinch. Lasagna sheets are extruded flat and cut to size, requiring careful handling to prevent warping. Automated vision systems ensure that every single piece meets the geometric standards of the brand. Regardless of shape, all roads lead to the most critical stage of production, the dryer. The pasta enters the drying zone with 30% moisture, soft and vulnerable to spoilage.
Once inside, the pasta will not see the light of day for several hours.
The incartamento, or surface drying, creates a hard shell that prevents the pasta from stretching under its own weight.
To save space, the drying lines are stacked vertically, utilizing the rising heat. The drying curve is scientific. If the surface dries too fast, the moisture trapped inside will crack the pasta later.
Alternating between ventilation and resting allows the moisture to equalize throughout the strand. High-temperature drying pasteurizes the product and locks in the protein structure for cooking resilience.
As the pasta dries, it shrinks slightly, tightening around the metal rod.
Gravity is a constant force. The initial surface hardening was successful in preventing
After hours in the heat, the spaghetti is removed from the rods, rigid and dry. The curved loop used for hanging is removed and recycled, leaving perfectly straight strands.
The long goods are now finished, awaiting their final packaging.
Meanwhile, the short pasta shapes undergo a different drying method suited to their small size.
Rotary dryers keep the individual pieces moving, preventing them from sticking together into a block.
Intense airflow removes the surface moisture rapidly, stabilizing the complex shapes.
Vibration is used to transport the product gently, avoiding mechanical stress that could chip the edges. For short goods, a multi-tier belt dryer is used, allowing air to pass through the pasta layer. The air flows through the product bed, ensuring that the pasta in the middle dries at the same rate as the top. Dropping the pasta to lower levels redistributes the pile.
Tons of water vapor are exhausted every hour as the pasta reduces its moisture content.
The structure is now rigid, but the internal moisture is still equalizing. Broken pieces and dust are filtered out to ensure a clean final product in the box.
A clean, glassy fracture indicates perfect drying. A crumbly break would mean structural failure. The drying is technically complete, but the process is not over yet. The final stage is a long, slow cure in vertical silos to bring moisture to exactly 12.5%.
Gravity gently feeds the product through the final stabilization phase.
Any remaining thermal stress is relieved here, preventing the pasta from shattering in the box.
The environment is gradually normalized to match the warehouse conditions. Dust is continuously removed to keep the product polished and clean. Automated sensors manage the flow, ensuring the silo never overfills. The pasta is released, chemically stable, and ready for the final temperature drop. Even distribution is key for the final rapid cooling stage.
A final blast of chilled air locks the structure permanently.
The transformation is complete. The soft dough is now a durable, shelf-stable product. The finished goods are sent to massive storage silos to await packaging orders.
The resting hall houses tons of finished pasta, organized by shape and production date.
Before packaging, a sample from every silo is cooked and tasted. The cooking time is verified to ensure the instructions on the box will be accurate.
The texture must be firm to the bite, with the signature resistance of high-quality durum wheat.
Clear cooking water proves that the starch structure is strong and didn't leach out. With quality confirmed, the silo is unlocked for the packaging lines.
Even after drying, a final optical check removes any cosmetic defects. Safety is paramount. Powerful sensors ensure no metallic debris enters the packaging. Gentle handling systems prevent breakage as the pasta approaches the weigh station.
The product is distributed evenly to the multi-head weighing buckets.
The system is primed, holding a buffer of product to ensure the high-speed packers never run empty.
The computer calculates the perfect combination of buckets to reach the target weight with zero giveaway. The iconic blue carton begins as a flat sheet, erected instantly by the packaging machine.
Hot melt adhesive seals the bottom flaps instantly, creating a sturdy container.
The transparent window allows the consumer to see the product quality inside the store.
Gravity fills the carton, and a gentle vibration settles the pasta to ensure the lid can close.
Long goods require horizontal loading, sliding the bundle carefully into the carton.
The top is sealed, and the package is now a tamper-evident, airtight unit.
Traceability data is permanently etched onto the carton, tracking the wheat back to the harvest field.
Any box that is even 2 grams underweight is automatically rejected. A final safety check scans the sealed package, ensuring total consumer safety. The individual boxes gather, ready to be grouped for shipping. The individual boxes are collated into bundles for easier handling by retailers.
Heat shrinks the film, locking the 12 boxes into a single, stable unit. Heavy-duty shipping cases are prepared to protect the product during global transport.
Robotic automation handles the heavy lifting, loading cases with tireless precision.
Sealed and secured, the case is ready for the pallet.
A unique logistics label directs the case to its final destination, whether Milan or New York. Gravity assists once again, bringing the finished cases to the palletizing zone.
The foundation of logistics, a standard wooden Euro pallet.
The robot builds a perfect interlocking pattern, ensuring stability during transit. Stretch wrap secures the load and protects it from dust and moisture in the warehouse.
The production process is finished. The logistics journey begins. In this cathedral of inventory, pasta waits for orders from around the globe.
From the fields of Foggia to the family table, the supply chain is unbroken. Every day, hundreds of trucks depart, carrying the result of precision engineering and natural ingredients.
The final test of quality happens not in the lab, but in the kitchen.
And this is how modern factories produce inside a Barilla pasta factory. From durum wheat fields to blue box spaghetti, from start to finish.
Where tradition meets technology to feed the world.